Hi, and welcome to our discussion on hygrometry. We're working our way through the different types of instruments that measure water vapor in our atmosphere. And we are now looking at how water vapor is absorbed by objects and how those objects can tell us how much water vapor was absorbed by their changes. So this is what sorption is. Sorption is the taking up of one substance by another. There are two different types of sorption, either adsorption or absorption. You probably never heard of that or never realized that. So let's go through the differences. Absorption is when one object takes up another one, and it may combine chemically or may result in a physical change of solubility. And adsorption is where a thin film of fluid will form on a solid substance. So it doesn't really combine, it doesn't create a solution, but it just produces a film on the object, a water film. So different objects result in the absorption or absorption of water vapor. You can imagine some of the things you see in common practice every day. For example, wood. If it's very humid, you notice that your doors will stick. The reason for that is because wood tends to absorb water vapor, and when it does that, it expands. And when the relative humidity goes down, the water vapor leaves the wood, it dries, and as a result, the length or the thickness of the wood decreases. Your hair is the same way, actually. It'll adsorb, actually, water vapor. So, looking at how absorption hygrometers work, here's some desirable characteristics. It must be reversible, meaning that for the same amount of water vapor in the atmosphere, you get a certain measurement for a certain amount of water vapor. The water vapor goes up, you get another measurement, it comes back down to the same value that you had previously. You should be able to get the same value from that instrument. Also, it should be reproducible, meaning that you do it many times going up and coming down and you get the same values for the same amount of water vapor in the atmosphere. Has to be detectable. In other words, you should be able to notice a change in whatever instrument you're using and how it absorbs or adsorbs water vapor. Hygroscopic means that it tracks water. It doesn't shy away from water. It actually goes out and physically attracts water. And then porous means, of course, that water is very easily attracted by it or comes through its pores. There are different types of sorption type hygrometers. We're going to look at the ones that work on electrical principles first, and then we'll work our way later into mechanical ones. Of course, electrical hygrometers use some sort of electrical principles when the object takes up water, when it adsorbs or absorbs water. And the most typical properties that change, there's some electrical hygrometers that are based on capacitance and other ones that are based on resistance. So a capacitance type device, of course, when water vapor is taken up by this object, the capacitance changes. Well, what exactly is capacitance? Capacitance is the ability or how much a device can store electrical charge between or a given distance between two charged plates. So in other words, it says there for a given electrical potential, what we mean by electrical potential is the voltage. So you apply a voltage in a current, and then you've got two plates that are separated by some distance. So the current can't flow. As a result, it charges one side of the plate. The other side of the plate has an opposite charge, and that sets up an electric field between those two plates. So electric field means the electrons want to flow from one side to the other. How easily it flows from one side to the other depends upon what's in between those two plates. So what we do is we put a polymer between those two plates. something that will absorb or adsorb water vapor. So the polymer will attract water vapor depending upon the amount of water vapor in the atmosphere. In other words, the water vapor pressure that's in the atmosphere. And that polymer will result in a change in the capacitance based upon how much water vapor it's able to absorb. Here's the equation for capacitance. Capacitance is equal to the area of those charged plates divided by the distance between those two charged plates times this epsilon, which is the dielectric or the permittivity of the material that's in between. The permittivity or the dielectric constant of a polymer that's used for hygrometry might have a value of 4, but if it's dry, completely dry, but water itself has a dielectric constant of 80. So in other words, as this polymer absorbs water vapor, its dielectric constant actually increases, and that'll increase the capacitance of this circuit. And this chart shows the increase in relative humidity with the increase in capacitance in picofarads with the increase in relative humidity along the bottom in percentage. So here are some characteristics of electric hygrometers that are actually used, the ones that are used for capacitance, that have capacitance type devices. They are slightly nonlinear. We didn't really see that in that chart before, but in some parts that is slightly nonlinear. These devices also, since the polymer is exposed to the atmosphere, they tend to get dusty, and dust, believe it or not, absorbs water differently than the polymer does. So they need to be cleaned. Also, the polymers may have a little bit of chemical change over a period of time. So as a result, you tend to find some drift in the calibration of the instrument. And also some literature says that there's some problems with the conversion from capacitance to voltage. I really don't have any more details on that, and you'd have to dig into the particular instrument to find that out. One of the more ubiquitous hygrometers, capacitance hygrometers, that is used in our world today is made by a company called Vaisala. And they have a little capacitance type device they call a Humicap. Huma for humidity, cap for, of course, capacitance. And its model number is the DTS1. It uses a thin polymer film in between, of course, two charged plates. They say that it's insensitive to dust, dirt, and most chemicals. It's very accurate, it has good stability, and really not much hysteresis. There's some pictures of what it looks like. Believe it or not, these are the standard for the National Weather Service on most ASOS stations, actually all ASOS stations. It uses the Vaisala Humicap. And it measures specifically, it measures relative humidity. It doesn't measure dew point, doesn't measure water vapor pressure. It measures the relative humidity. And from that, we can back out using equations and figure out the dew point and other variables. Here's some of the accuracy. Notice that when it gets really humid, the accuracy, believe it or not, decreases. But it's pretty good at lower values. And from 0 to 90, it's plus or minus 3% relative humidity. So as I mentioned, it is standard on ASOS stations. This is what we use to measure humidity, and from that we can figure out dew point, and that's what you see in the METARs. That's where that value comes from. It's also heated, and also they say it's maintenance free, but I know that the electronic technicians have to go out there every once in a while to actually take care of the ASOS and the sensors. So that's a little bit about electric hygrometers, specifically the ones that depend on capacitance. In another video, we're going to talk about ones that use resistance to measure relative humidity.